Hello colleagues, welcome to this demo session, and today I want you to demonstrate a few things from our site. It is about our KubeRocketAI declarative agentic framework for AI-driven software development, and I want to show you the idea behind this framework and how the things are moving under the hood. So welcome. First of all, let's start from the brief overview of what is this framework about and which problems we're trying to address. So the first of all is, I know that many of you using today AI, like in many sense of your delivery, like starting from defining your user stories, like writing tests, generating code, and do a lot of stuff from management perspective to, let's say, to deployments. And what is the general, which is like all about these use cases, is that for each of these steps you must have a predefined agent which well know what to do in each specific situation. And for these cases you always write some custom system prompts, define your agents, define capabilities of these agents, and share somehow, like storing in your ChatGPT or in your personal GitHub repositories, then share the links or any other kind of sharing capabilities. So, and at some point of time we did the same way. So each of our repositories for our KubeRocket CI platform, which is about like microservice delivery within Kubernetes, we did the same trick. So for each repository we start storing like specific rules for example for GitHub Copilot, because initially we use it as our first, let's say, AI tool. So, and we started to populate it with the rules, project stuff, etc. But then at some point of time we realized that we have like a lot of repositories under the umbrella of this platform, and each time we need to copy paste different system prompts from one repository to another. If we have some updates, then we need to ensure that these updates are delivered to different repositories, and that's actually the problem. So you need some mechanisms that allows you to track this up-to-date version of your system prompts across your project, because you might have like hundreds of code bases that might use system prompts that are shareable. If you have some cross-cutting concerns, for example, ticketing stuff, creating bugs, etc., and as well as code-based specific stuff, front-end, back-end, architecture document, so etc. And this brings a huge effort for you to somehow organize the repository, how you need to store those agents. And now imagine that you are using different IDEs. Maybe it's not through your company, because in your company you might have some enterprise solution that like have rules on how to apply and work with the agents, but you might have developers, you might have vendors, you might have your colleagues from other organizations that might leverage different capabilities of LLMs. And for example, they might use different IDEs for the development stuff. And that's actually the problem. So if you want to share something, you can just copy paste with your Slack chat the system prompt, or give a link to your repository like, hey, here it is, please check my new agent that I have updated, and use it. So now what we propose, and what is the problem? The problem is that you might have a gap between what you have today and how this system of agents evolving through the time. So you need to ensure that it is up to date, that if you addressed in you, for example, requirement to a Jira ticket, for example, mark all tasks that created for this epic under some specific label. So, and you need to ensure that all your agents that you're used across your environment aware of this situation. And that's the case here as well. So you need somehow to ensure that all your agents consume the same data source, and at the same time they are able to work on their specifics. So, and here is what we're proposing for you is KubeRocketAI. It's a consider this as a pipeline as code or infrastructure as a code approach when you store all your agents and the assets that belongs to these agents in a simple markdown version control on the GitHub or Git repository, and that allows you and brings you all the capability of Git, like traceability, review, CI/CD pipelines, validation, security checks, context check, review from from security team perspective, etc., etc. And at the same time still be on the no code or low code stuff when your target audience is okay to work only with the markdown, with the natural text, and do not dive into specific Python libraries of implementation and communication between different agents. So here is why we propose our solution. You can use it to deliver an agents and customize agents for your specific purposes and bring it through your organizations on the code base level. So imagine you have a single repository with the golden agents definitions that you keep up to date. It's like in the pipelines in your DevOps ecosystem. And then you also have some specifics for each code bases that are stored together with your code base. So with this approach, you can declaratively support your ecosystem across different code bases across your solution. So on this screen you can see just how the things looks like from the perspective of architecture. So you have your existing tools, you have your lovely IDE, for example Cursor, Windsurf, GitHub Copilot, whatever, and you just leverage the capability of our KubeRocketAI framework. It is like currently consists of command line tool that baked for your agents. Definitely those agents are currently configured for some specific rules, but you are free to extend those rules to your own needs. And these rules just shows you on how you should define the agents, how you should define the actions those agents should perform, and how to organize these interactions between different agents. So this is how it looks on the high level. The quick start is just go to installation section. You can use, if in your Mac OS you can use Brew. In Linux you can just download and install the binary. The same stuff is for Windows as well, and the simple usage. And I think that today I will demonstrate all of these capabilities with end-to-end scenario. Maybe we'll try to cover all the topics and all the agents that we have in our SDLC flow. So that's why let me first to show you how the actual system looks like, so you understand everything that is running under the hood. So originally our repository contains agents defined in core library, and this core library is installed using command line interface. So the library contains agents, data sources that can be consumed by tasks, and these tasks are performed by agents. And also agents and tasks or data tasks consume templates, so they show how agents should output its results. Okay, so and we also have adaptation of each agent to be started with any IDE. So it might be Claude Code, it might be Cursor, it can be GitHub, Copilot, or Windsurf. So we definitely can add here more IDEs that emerge on the market. So how the things work under the hood. So we have an architecture repository. So originally it was developed using this framework. So we're doing like a kind of dogfooding. So again, we have the same agents here, they install it, and we just working on our solution starting from the very beginning. So what does it mean from the very beginning? So in short, as I mentioned, our repository or our architecture on a high level can be presented by this picture. So I've shared this diagram as well as a separate as a part of this video, so you can get acquainted with all these details. And what is actually important here is that we have like 4 major components. So let's say agent, who is persona, and tasks, so what are the capabilities of this persona, then reference to any knowledge base or constraints that this persona should behave, and also and how, so how the result of this task should be presented. And this is actually, you see on this slide. And now let me go to SDLC framework part. Actually, this is what we implemented inside our framework. So originally you come with an idea of what you want to implement, and then this idea can be transferred to the project brief with vision and strategy. After you have a project brief, you just define a product requirements document that can be later transferred to epics, architecture, design, and later like break down to stories, and then finally like to tasks, subtask, and code implementation, and finally check it with your quality controls. So we have a number of personas inside our framework. They are defined on in this document as well. It is also available as a part of the framework documentation, and each of these persona belongs different responsibilities and dependencies. So here as well, those dependencies and these dependencies defined on this slide. So initially we start with the product manager, who's responsible for the PRD, for the requirements, together with the business analyst, and can work on some problem and identify the use cases you need to cover with your product. Also, a product manager can partially delegate, or if you have a separate role of product owner, start working based on these high-level business requirements, start working on epics, and help to define stories on a high level that need to be implemented under these epics. And then let's say we're doing these iteratively. So product owner can return back to business analyst for details, product manager. So it's constant like feedback loop between those personas and artifacts they are producing. So as soon as we have some high-level understandings on what we want to build, we need to ask an architect on how to build this. And architect also consumes previously generated artifacts like PRD, project brief, maybe some data sources, and provides an architecture document on how to build actually the solution, how to achieve the goals that are defined by business. So architect then picks those artifacts as an input source and then produce an architecture document. It can also like do an iterative consultation with developers, with other architects, with business analysts, and clarify epics and stories as well. So finally, when the stories are ready, together with the product owner, we can also ask any feedback for the developer. So developer can validate some specifics related to code implementation, to specific library usage, etc., etc. So, and after that, developer can produce an implementation plan on how he's going to achieve the goal and implement this solution. And after that, so we use a QA engineer who can like run these validation tests, ensure that what is actually we want to build is actually works as we expected, and provide a feedback to our as a part of maybe user acceptance tests. So we can optionally have a DevOps engineer who will be responsible for deploying and supporting infrastructure And this is how the things are working. So this is also document available as a part of documentation. So there is a well-defined diagrams on who is responsible for which part of the job and what are the artifacts are required for each input and output source. And the idea behind our framework, which is implemented inside these agents, is actually to follow this pattern. So this KubeRocketAI AI folder, it contains the rules on how these idea should be covered to actually running code in production. And using those agents one by one on different stages of your project delivery, you can achieve like a success with getting all what you need. So you can customize agents for specific frameworks, for using specific libraries. And today I will show you how it works today for Dogfooding, actually the framework itself. So this is currently state of our framework. Again, I'll return back to the public repository, and this repository also contains the information I've just shared, so you can review. There is also a quick start. So idea of a quick start is that first install the framework, then depending on what IDE you are using, you can install it, and then check the agents I've just mentioned before. You will see like these C agents out of the box, so you can pick up any agent you need for your current task. For example, this can be product manager that can create project brief. If you're just starting something new, then you, based on the system prompt, this agent will guide you through the process of creating a professional 2-page brief, project brief that can be further used to, let's say, to extend it and to transform it to the PRD, to your product requirements document. And that's actually the beginning, and then you can follow the schema I've just mentioned before. There is also a validation steps inside the framework, so they are guaranteed that you don't have like broken links, that you're aligned with some specific business logic. And actually this is the part we want to extend and to add like token calculation for system prompts, checks for different stuff like using local agents, and etc, etc. So now let's move to our next step, and this is about let's just using our framework to introduce a new capability of our platform. So one of the capability we want to have on the platform is that the support of local agents. So what does it mean, local agents? It means that you might have a repositories or code bases that require some customizations for your agents, and these are only belongs to the specific or that specific code base. For example, you have some library that is used only for these code base, and actually you want to keep it together with the code base, like a custom pipeline that performs some specific logic for this specific implementation. And here is how we start. So imagine I need to have this feature. So this feature is not yet implemented inside the framework. And first of all, what I need to choose my favorite IDE. So let me open Visual Studio. Again, it depends on different IDEs. So I might switch between different of them because we have different configurations available for each of these IDE. And today I will try to go through all of them and show you how I can switch IDE and how I can switch agents. So first of all, what do we have here is that, for example, this is our KubeRocketAI repository. I already prepared some structure before, and this is the structure that is expected by agents. So you might have a PRD in the root of in the docs folder of your project. You should have like project brief, epics, architecture, and also stories. So the stories that are implements functionality of the product you are building. So now let's start simply with the first task. So first of all, we want to have we want to have, for example, together with you, let me select this model, and let's start from the product manager. So the idea is that we as the business owners just understand, okay, so we need somehow to provide a support for customization. So let me do this, and let's say write a help, like we can asking our PM, so what is the capability of you, so how can you help me with achieving my goals, and how can I do some specific stuff. So, and I see a welcome message. So while it's running, I'm showing you what is actually happening under the hood. Since we're currently in GitHub, so these files are actually working, and we have selected this PM manager, and this is actually his activation prompt. So we see that here is the list of comments that this agent supports, and the list of tasks this agent can perform. You can extend this list, but for now we just concentrate on our specific purpose. For example, we know that we want to update PRD. So we want to update it because let's say a new requirement, business requirement emerged, and we just want to correctly trace it through all the stack of our documents to ensure that everyone on the same page, that architects knows how to implement it, business analysts can get some insights from user use cases, and then developer understands what we need and how to build it together with architect. So what we have now, so before making any changes, I need to understand your requirements. So again, the idea is behind that is that this agent, you can see that we selected an update PRD, and it goes to our framework core, and then in tasks it search for update PRD record task. And here is the steps that the agent must follow. So, and again, you can write your custom tasks for your specific needs and define the logic you want the agent to follow. So now let's concentrate on our specific topic. We're talking about that we want to have support of local agents. So let's write this. We want to have capability to support local agents, so we can store them together with the specific code base. Maybe, again, this is our assumption, maybe we need only custom tasks and templates and data sources specific to these code base. And in this case you can in this case we don't need agent on the code base level. For example, we have developer who knows I don't know Go language, and we can use this role, but provide a specific guidelines, use specific framework or specific library for this specific code base. Let's discuss this and create BR. So we just provided to our agent what we want to achieve. So and again, maybe we should still stay on the business level. So we don't want dive deep into the details, because this is the part where architects can step in and validate this together with the developers, with business analysts, maybe with the product manager, product owner as well. So what we can see here is that again, local agent support requirements discussion. So you need to add capabilities, so full local agents, complete agent definitions, or store only local artifacts. Again, maybe this is not the part where business owner just decide on a technical solution. It needs just to say, okay, I want just capability for users to be able to define custom agents, and that's it. How it is going to be implemented, this might be a headache of the architect. So what we see here, so for the local, it proposes some structure, and then you can say like, okay, I like this and should go this way. And here are some comments. So when you say we don't need agents on the code base, do you mean use shared agents but with the local task, or completely eliminate? So we can say so. Again, we can use this approach, but this might be on the architect side. Then for the second one, we want our use shared, for example. For the third one, these can be discovery and priority. How should the system handle conflicts? So should local? Yes, local should always take priority. So this is a great question actually, because you might have a conflicts between agents and data sources. So use cases, so project specific, custom tasks for unique projects, sensitive data, custom templates, etc. And based on your decision, so here is my initial business requirement. So user can define and use local agents stored with a specific repository over global enabling. An alternative B, user can store complete local agents. So I like BR1. I like BR9 with the first approach. And architecture implications that definitely would impact some epics, but we're okay, I think, with this, because we are okay with arc implications, since the stories, okay, let's go, since the stories are all the epics are already implemented and don't just touch them, don't change them, create the new one. Okay, so which approach do I prefer? Local components only, or full local agents? So the questions to answer: use local, directory structure, should local components live in the project, priority model, show installation flow, should initialize local agent support. So let's say, so answers, let's put answers and say local components only. So I'm thinking that we should use share agents as much as possible, because they are more standardized. But again, in future, if you will create a request for us that, oh, you want to store a separate agent for your specific case, just let us know, and then we will definitely can introduce new business requirements and align to it. But today, let's simplify the thing and store only dependencies for our local agents. So local components live in project, and it can be like this one. Again, architects might come in and say, I don't like this approach, let's change it. And then priority model, so local is prior number one. Installation flow, but again, I know that the framework provides us the capability to check the links reference, so I think that the problem 3 even will not, I think this problem will not happen, because we define our dependencies statically in defining the agents. So since we have static definition of agents, and the last one, and the installation for how should team initialize local agents to port on their own, just just following the agreement. So we need to define some agreement on how we should define this structure. And now I push it, and let's consider and let's check what is the answer of the agent. So again, it reads some specific requirements for our framework. Yes, so we have like a reference who is responsible for which stuff. This is what is described for you. We also have a business requirements and actually the PRD template, how it should like. And then our agent knows the structure, goes to the implementation phase. And remember, this is still like product manager who is on top of the solution, who is the pay for this solution, and then he defines what to do. So he wants together with me, with business analyst, like we need this local support because we have a use cases, like a huge amount of use cases to use this. And actually this is the good pattern for pipelines as well. So a lot of CI/CD tools like leverage this capability to be able to run something from the shared golden library or run something specifically defined that is lives together and evolves together with your code base. Okay, so we have defined like business requirements, separate like here it is, it's business requirement number 9. We also have a non-functional requirement that system discovers within 1 second. Again, you must each time check what is actually changing, because this helps you on how the feature is going to be implemented, or where the agent follows the way you are thinking. So it will help you to ensure that what you will finally get as the result is what you actually was expecting. So it's still working, so let's wait a little. Okay, let's check what is actually changing. So it's still working on this document. Let's wait a little, and as soon as it will be finished, we just speed up this record, and as soon as it will be finished, I will return back to you with our next plans. Okay, so what we see here is that so we successfully created PRD, and we just go for Epic 6. So we just created an Epic 6. Let's open the Epic 6 and check what is actually here. So the Epic 6 defines, and we also have stories. Let me store them. Let me store them and make another review. So as the part of this epic, we just define that local agents components. So we define some business value, solution, requirements mapping, like why we need this stuff, and then we define an epic component. So again, I can read the stories. So as a developer with a project specific, the system is automatically discover local components so that my customization are available without configuration. So this is a good stuff. We can also check other stories and successful criteria. So local components take absolute priority order. So I'm not sure that we need actually this story, because we can redefine it, okay? Just not to duplicate something. So we can merge actually the story 1 and the story 2, because the story 1 can consume and use the same acceptance criteria. So the next story is developer creating project specific customizations, so to organize local using familiar directory structure. So again, it's like it might have the same approach as we already have previously. So I don't see any reasons to have story 3 as well. So it looks like we can implement this for one single story. Okay, now we want to validate our epics and our stories that was produced by the product manager. Let's select the PO, the guy who can help us with the stuff like creating epics, updating stories, review, etc. So I will select this guy. And let me start maybe from the epic first, because epic can be shaped, and then we can manage the dependencies of this epic. So I'm just putting a help for this agent, and he exposed like, hello, here is my capabilities, and I want from his side is to like run for, or we can say like update epic and say epic 6. We can define it as a file, or just saying like 6, it will just search through the epics and find what we need. So again, it searches and finding the tasks that he needs to perform. This is an update epic task. It defines the instructions on what the agent should do with this epic. So and here is his help. So what can I do for you as the part of the update process? So what should we need? What should we look at and clarify something? Okay. So what we need to do is that first of all, we need to review this document. Okay. So we need to understand that what is actually here is that, as I mentioned, we have like 3 stories created, 1, 2, 3, and each almost has a lot of commands in its part. So we can actually implement it quite simple. The very important is that we agreed that the agent is still shareable, but the components that can belong to the agents are not at the part of this customization or local file storage. So now let's review stories and elaborate. You can also run like a deep think or run deep think. Do we really need 3 stories, or we can combine them? There is also tools that I'm heavily using for different use cases. Let's enable sequential syncing. So sometimes it helped like to brainstorm. Again, it doesn't mean that always use this tool, but for some of the cases, it's very valuable to have at least some more feedbacks from the perspective of how the things are shaping. So I just put this for our agent. Now it's like starting like thinking about what we need to do with our epic. But okay, let me allow in this session. So again, it runs sequential syncing stuff based on my question, but again, it doesn't mean that you always need to ask for the help. So from my perspective, what I see, it's not so like difficult, and we can definitely combine all the stories into a single one. Yeah, it will be rather huge, but again, the acceptance criteria are very well defined. So we have a specific directory structure. So we need to ensure that our local structure contains these folders. Again, but what if we don't have templates in our local folder? Is it like a failure or not? So we can define all those different edge cases and plan our implementation together with architect, with the developer, to validate like whether we expect that local should always contains like tasks, templates, data, or it's okay to have only those that is specifically defined. So how we need to behave in this case. And again, this is a work that you need to do each time. And for example, AI agent is our PO is also proposing like local components override system. So with a project specific, I want to store and use local agents components that automatically override global ones, so they customize project's workflow. So system discovered local components take absolute priority over global one, discovery and resolution 1 second. So everything is like here. And option 2, story like structure and discovery, and priority logic and override. So let's combine. So let's have 1 story. And now we need to expect that that the first of all we will update the epic. Again, agent reads the epic template, so it always aligned with the output that we expect from agent side, and then updates the epic content based on it. So the sections you see in this template are defined, so you can change them for your specific needs if you believe that something doesn't work for your SDLC, for your workflow. So let's wait while our agent is working. Okay, so there is also some technical details stored in Epic. Actually, I really don't like to have much technical specific stuff into the epics, but again, it depends on your rules on the projects. So I try to keep like epics more, let's say, business oriented, and at the same time put some significant decisions that might impact the implementation of this epic. So let's keep this. Again, for the sake of this demo, I'm just keeping, but definitely usually I spend more time for polishing the results. Okay, so business requirements, non-functional, user stories. So phase 1, it has, like, you see that it proposed to use phases, and it's the only one phase, so definitely we might agree to remove it, but let's keep it. So the developer definition, directory, so dependencies, technical implementation, dependencies, risks, what we need to do. Okay, project specific, templates. Okay, let's stop on this and then proceed to the next section. So I will just polishing this document a while. We'll just speed up this record, but I'm not going to comment a lot, just to not take much time from your side. So let me check it on my own, and then I will provide you final result of what we should have as the final decision. Okay, let me return back to this interactive mode. So what I want to have here is that maybe we don't need this least local verbose. So we don't need one. So we also don't need this resolution test. We don't need like structure local tests, so local references, because we already have like a lot of stuff for the implementations. So in this case, I can say like, okay, let's update acceptance criteria. So the framework already has a good validation approach. The framework already has good validation approach. We just need to ensure that defined files in local exists. So we are not expecting changing anything in CLI. So actually this is true, because again, how the validation stuff are working. So if, for example, I will run validate for now, and you will see a framework valid. It finds and discovers like architects, dev, PMs, etc. So if you go to any of these agents and define the task that is in a KRCR, for example, local task, then it should work. Okay, we definitely need to align our YAML schema, and that's a good approach to find this. So this is what we need to do for sure, and this will allow us to work with our log agents. The same is true, must be performed for maybe for the system prompt. So we need also check this as well. Now let's check what's actually here is that, let's not save this. So let's check this acceptance criteria. So framework existing validation ensures defined local files exist and are accessible, like local ensure mirror global components, local blah blah blah. Yeah, again, some of them can be removed, but still let's keep it for the simplicity, and I'm okay. Now let's align stories. So we need to align stories because as the result of this activity we have only one story as the final approach. So we don't need story 2 or 3. So let's wait the work of our product owner and understand what he's going to perform to ensure that we still have integrity in our definition. So archive or remove. So it's going to do some of the 2 approaches. Let's wait for his final decision, and I expect that the only one story will persist and the rest one will be removed. If they will not be removed, then we do this on our own. Okay, let's wait. Okay, so the story 1 was updated. Let's keep it. So let's keep this story, and it proposed to deprecate, but I want to say you are free to remove those stories. So we don't need any like backup logic. So it will just ask me like, can I run a remove command? Yeah, I'm okay with this. And let's also remove the same for this story, for the next one story. Okay, so the Epic 6 is finished, and now let's check how the actual story looks like. Okay, let's close all other documents. Let's return back to the story and let's check it. So what is actually inside this story? Let's review the story. Again, it is currently in draft status, so we can check the story and say set it to approved. Again, for the simplicity, I will just a little bit speed up this because I want to show you an implementation approach as well and how it works. So let's read it step by step, understand its business requirements, whether we aligned with the acceptance criteria, and also the story is built upon, again, our templates. So here is the template of our story. So the agent leveraged this template, put it inside story, and populate it with the required components. So the acceptance criteria. So system discovers local components. So validation, local components can be completed within 1 second. Okay, what is actually here as well? Local capacity absolutely priority. So directory structure compliance. So it must be compliant. So local components can reference other local components. So we can definitely use this trick. So I can create, for example, task, and these tasks in local can reference to data source in local as well. Clear logging shows global with debugging. Not sure. Let's actually remove this because, again, we have a common approach to validation. It is rather generalized, so we don't need to invent something that we need for the local folders. But if any of you watching this video are expecting to see that it is specific the issue with the local component, you can highlight it and we can change business requirements to this. And documentation example is good catch because maybe we want to show how the things should be implemented. Okay, so now the section is the descriptions. with some description, and then the task and subtask. So this is a very important step here, because our developer guy, who's the next after this story definition is going to run this stuff, is going to perform the steps. So we need to ensure that these tasks and subtasks are aligned with the implementation. And this is where one of the most huge part of the work should be performed. Okay, so this will take time for myself as well, and I will try to go through this task list and then return back to you with the feedback on what we have and what we don't have here. Let me start from the very beginning. I will try to do it in interactive mode. If it will require more time, we'll just speed up this video to save your time. So we say that we want also to define local scanning. Maybe yes, but we need to understand what does it mean scanning, because again, we are the part of framework. We are free to move everywhere under the KubeRocketAI AI folder. Maybe it's good part to hear is that we must standardize those local folder. So we must say that no one should store anything here except those 3 files, and that might be a business logic, and we might force user not to put here anything like my homework, my home task, my Jira, but just keep the things dry. Okay, so I'm vote for this, and I want to ensure that that we just align to this structure. Ensure directory completes, validate and validate local components. So we can definitely add like ensure no other folders, like we can say like ensure no other files or folders exists under KubeRocketAI local except the defined structure. Okay, so the next one is the priority resolution. I think we don't need it, because again, on the agent levels you define where to grab tasks. Okay, so you can define whatever you want, and our static analyzer will check this link whether it's broken or not, and also our LLM will also do this check because it has it part of the system prompt. So let's say in this way we need to also we can also say like align this is the align JSON schema to support local components definition. As you remember, when I went to this folder and starting like putting something like KubeRocketAI, but putting here local, you see an issue with our schema because it has some validation stuff. So that's why we need also to ensure that our schema will be updated. I've put this here, and I'll later show you a trick how we can treat with this item. So the next one is a priority resolution. So I think I can remove it. I don't need it. So component reference, enable local components. But again, it's also like we still can reference local stuff, but maybe we can elaborate on this specific use case. So we can say, we can try to search whether any forces, flags, or any other business logic that denies for creating a local folder, but I don't remember it. So let's remove it also as well. So logging, debugging, we also don't need it. Examples, and let's keep it here as well. And let's we can also say like generate examples for local agents, and like to store something to store something to show how it works. Okay, so and now I say that okay, I've updated story on my own. Please check the changes and let's elaborate. So I just also need to provide a feedback. Why? Because we have here an acceptance criteria, yeah? And if for any reasons, like we still have like acceptance criteria number 3 and it is defined, it's okay, but what about like local component preference? And here is what we can have a feedback from our agent. So it provides like elaborations, whole schema alignment, JSON to support. This is interesting. Questions to elaborate which specific JSON schema. Again, it tries to answer ask the questions that it's not aware of, but I can put it in context and it will find this. And I think that we can do this by the developer later. You need to add requirements, no other files. Okay, questions to should you be able to enforce? Okay, let's start with the question number 1. So we have I can say like this one. We have JSON and here it is, like assets, this one. So we need to align. So what it means? It means that AI cannot like see everything, and you as a developer or architect knows your code better. So you can ask what to do or how to do and in which places. So I'm just answering. So we need to align. We have like, so we need to align. So the second question, strict directory. You should this be enforced with validations work or hard errors? What should happen if users add unspecified? Like it's good question. So should it apply hidden files as well? Yes, it must be strict. So we can see only 3 folders there, like tasks, templates, data, and nothing more. If we see something else, just this is violation of our validation flow. Okay, so the next one is the third question. So simplified implementation. So you remove several implementation, like okay, align, AC as well. So acceptance criteria should be as well. We are okay to remove those requirements. And the fourth question, story scope refinement. So story now focus more on discovering documentation on the complex resolution language. So we don't need complex resolution. We have validation framework that does this stuff. So we don't need it. Okay, and we have dependency engine already in code. So we need to use these capabilities. Okay, but maybe it's going to be another person who is going to put up very good details to our story. It might be a developer who knows well how the code looks like, how it works, and what we need to do to achieve our goal. Again, it's an example of how you should deal with your target solution. It's more about defining the architecture, defining the shape of what you want to get, and as the result, agent will follow these rules, and you will less be more, debugging, fixing something that was implemented in a correct way. So my advice is, well define your architecture, your target solution, your business requirements, and you will get exactly what you expect to have. by the way, this agent was also quite good because it went to like agent schema and even put this information here as well. So let me keep it. So next implementation priorities. So it also put something here. Let's check what we have. So components discovery, schema support, strict. So you see that the acceptance criteria like changed based on my feedback. Okay, let's stop to work with this agent, and now let's switch, for example, to another my favorite tool is a Claude Code. And again, because we have adoption for different IDEs, you can switch among different IDEs. So for now, I'm showing you to how can we work together. Okay, let me start it in, let's say, in more plugin way. Okay, so what we have here is let me start. So again, I have defined a comments. So I know that Claude Code like introduced the sub agent, so we're still in the process of evaluation and migration. But today let's still be on our with our developer using command approach. Again, what we need to plan story implementation. So I say I'm just saying dev hello. So he's loading. He finds like all the required things he needs. So I need a plan implementation, and let me say that it's going to be our story, this guy. Okay. Now again, based on these tasks, let me show you how this task look like. So let's go to tasks, plan implementation story. We see that this specific developer concentrates on technical implementation part. So he's responsible for understanding and populating this section. Okay, so this agent loads the required assets dynamically. So it doesn't load like all architecture document because he doesn't need it. So he just loads what he needs, like plan the story template itself, SDLC framework, because there are some rules, some general rules that shared across different agents, and then start like checking. So again, based on these tasks and how well we defined, it can still use them as an input source for validation. So it starts like checking what he needs to do, what he needs to check, maybe like running some simple configuration checks, some planned technical implementation, and then enhance tasks subsection with the execution itself. And this is another like interesting approach that again you are concentrating on planning in the most cases, and the coding is the last step. Definitely you should better know your code, so you must work on it on this code and understand whether your agent produce what is expected. Let's keep this. So you see that the agent put more details in the description section. Okay, so because the agent is instructed to extend the sections if it needs more information, and you see that it also puts the path to the required files to the proper places. Definitely, if you're aware of whether it's correct or not, you can check, you can fix, you can update, and then proceed with implementation. So you see that how this implementation plan agent does low-level planning stuff. So it goes and puts some even functions in the functions levels, and this is because again we have the code in the same repository. So actually this is our KubeRocketAI repository, and it just uses this structure, understanding on how it works, and adding this to the implementation context. Okay, let's wait a little. Okay, so the agent is done with his part. So what he found is that like technical analysis complete, implemented context added, like patterns, assets, task enhanced, like what to do, how to extend. It's like configuration, and there is also, you see that how it's going to check that our schema is actually valid. So he's going to check tasks and local tasks, but this might not work. For agent it will works because this is the only agent schema. For templates and data, we are okay to use any path we have, and then static validation will check the issues. So it even puts like file modifications, like what to do and how to do. Okay, I think we're okay with this story. Now let me show you how they actually we work further. So let me resume the last section. Let me resume this last session. What I forgot to do, it's still not a part of our framework, but this is what we agreed together with the team. So we need to put, and also this is going to be a very visibility part of how the project is evolving and where we are moving. So we need to create an issue in here. So let me return back and ask our agent, okay, create issue, create feature request in GitHub repository based on the story. Okay, you can use, for example, again, we can put this in a task in future to make this more in automatic fashion, but we can say use like issue 40, use issue 47 as an example. Show me the draft first. So actually I have an MCP servers defined for these for my Claude Code. So it is connected, so it can just use these capabilities, and we'll just transfer the story from this file to the GitHub. So this is a very interesting topic actually, because we have a number of questions and requests. So how these file system approach scales on an enterprise level, or on that level where at least you might have like 10 or 50 epics, and each epic can contains up to 10-12 stories. And definitely that might be an issue, because like file system will be growing, but it's still at that time it works, because when you have like everything in one single place, you can run a traceability stuff, like business requirement is changing, then you just search for the local file system for the BR, for example, number, and then change and validate in different places. But also we have a couple of ideas to change, to replace with some backend, with Jira, with GitHub, and to make this stuff. So like doing some low levels on the file system, but then replicate with target system. So it shows me what he plans to do. Again, you always review what is actually like here. So because it might be containing some sensitive data or something you are not planning to show. In this case, yes, please create, and it's not draft. So I must just to create it, and let me return to issues, and let's wait while agent will create this this issue for us. So the idea for the community is that we plan to put all the roadmap on these issues, so you can track them, you can check their statuses, you can propose your own features, as like I've just showed you before, and then we can validate together whether we need it, how it can be implemented, or even you can propose your pull requests using the same approach that I just showed you and shared. Okay, now let's finish this session because I want to start implementing this story. Okay, I'm a bit like I definitely need more time to review, but let me still stay on this high level. So what I just need to ensure that I can define a local templates like tasks, templates, so I can extend agent, I can define it. Okay, moreover, I can ask developer to run validation comments, for example. So I can ask in a QA checklist to run something differently for use cases. I can ask for add use cases that will validate this configuration. Okay, so now let's start again. Let's go to our Claude Code. So what we have, we call dev, our developer, and then we just ask him to implement. So we want implement, we're saying implement, and then we can just point this reference to this story. Let me check the changes on the Git we have. So we have some changes that I've just demonstrated you before. Let me remove this guy from here, and let's still keep the changes in agents. Okay, implement story. So let's go. Now the story implementations define in this task implement feature, and again agent should load all the dependencies. So it must ensure that it follows some coding standards, some best practices, and aligned with our SDLC framework. And now it's like status from improved setting to in progress. Let me put yes and like accept all changes for this specific session, just to show you from one point autonomy, and from the other side just not to have much time confirming something. But usually I just select a different strategy, like using a mixed approach, like something I want to validate definitely, something I'm okay to run in fully autonomous mode. Again, so the agent just follows this task and goes through the step-by-step list. It also must mark everything that is completed through the through these X for each tasks. So let's wait for his implementation. Meanwhile I can check what is actually changing. So we can see that the pattern to have support of these is also changed. So now I can define local tasks inside our agents and use it. So let's still continue monitoring what is happening. Meanwhile, I will just add to git stage on this changed file. There is also a good stuff that for each implementation task, it's better. I mean, I recommend to put some quality gates for each of these steps. So this will ensure that the code that is under implementation is validated each time for any formatting issues, for any linting stuff, for other rules that you defined on your project. So it helps you to have things working. So what is actually now going is that you see that it's like create some local invalid file. You remember that I mentioned that the only task templates data are allowed, and this is already implemented and validated as a violation. So this is how it happens. It just adds some code that ensures that we have this with this validation. Now it moves forward, runs different checks. Now it's on the task 3. We can ask, we can improve our task for the implementation plan to ensure that each time agent perform or implement something, it must like put done button, checkbox. But what I see is usually it's like going through all the list of tasks, and when it finishes the implementation, it's just like put done for all of these items. So we definitely can tune these to ensure that the agent does this trick each time he works on these specific tasks, subtasks. So what is the next step? It continues implementing according to the plan. Again, let's wait a little. We can speed up this video just not to wait too much. Okay, so let's return back to what is actually happening. So the good stuff is when you're running or implementing some code with the validation features, you can use them as quality gate as well. So since I've already mentioned that our framework already has some validating capabilities, it might check different use cases. And here is an example of how the agent like build this binary of this command line tool and then runs different scenarios to ensure it covers all the issues. So again, for example, now like it's seeing like we expect like number of 26 but see 25. So each time it iterates, understand what is happening, whether we need to change code. And actually I'm not expecting to change code much because we have already a validation approach. So the task is actually about aligning and add more strict rules for the repository structure to support local agents. So it's some just specific edge case which is already can be a part of framework. So we can even start with these local agents without adding this new functionality, because the design of this framework was originally to support different folder structure for the core components. So now we see that we started with the QA checklist validation command. So it checks all that we have as a part of our definition of the quality checklist. So it comes with each item, checks whether it works, and then populates it. Okay. And then the final is the implementation results section. So as soon as this code was implemented, in this section the agent puts some information. This information can be later used by you or by some other agent to validate like whether it's everything implemented as expected. And also you can validate whether it's like acceptance criteria are covered with these specific implementations. So what we have here is that files modified, quality assurance, quality checklist. Now let's go to the very bottom. So it's already moved story to the complete status, and it also like as I mentioned before, put the correct statuses of subtask and tasks. Okay, so it's finished and it's done with the implementation. The only thing that what we need to do is to check what is actually here. So the story was implemented successfully, let's say in fully automated mode. It was not so complex from the code perspective, but again, what we have here is that the checklist for is not like checked. Please check the checklist and mark as done if it was verified. Why this happening? Because honestly, if we go to the task itself of story implementation or implementation feature, then we have like mark X for task and some tasks. So the idea here is that the QA engineer should populate the checklist. So I'm not going to show it today because we're still working on our QA agent, but this is the idea, is that then QA agent goes to this story, picks it up and run this checklist, and only after that it will just put these items whether it's everything working or not. So again, we've just finished with the implementation. So we have only 2 changes, GTC, so it's not so huge. Okay, so what we can do, we can like run make build on our own, so and then run, for example, minus help, and for example validate. So we have like a number of agents. We can see that it created a local stuff with custom implementation and custom output. So it just puts some local configurations that leaves outside of the framework. But let's add them to our KubeRocketAI, because this is what we can use as an example of how the local agents can be used. So we have here like custom implementation, custom output, and data. So the data folder is empty. So let me do some tricks. So let me remove it and let me run validate again, so it works. Let me go here and, for example, create something like ABC, something that is not expected to be a part, and you see that it doesn't allow to be there. Okay, this is what exactly we want to have as a part of our framework. So I'm going to remove it and then run validation as well. Okay, I believe we are done with this. So now what can I say? I can ask now please for the staged files create signed commit message. Do not, again, this can be the part of your quick task, like create commit message and then put the details. It is not yet a part of our framework, so I won't just need to type it manually. Now please, for the staged file create signed commit, do not mention Claude Code, because it always try to put like Claude Code as a co-author. Maybe it's like it's correct, yeah. Do not mention Claude Code. Use conventional commit approach, and closes issue that we've created by this commit. So now I'm asked him to do this. He might want to add something new to our commit. So it usually wants to add story. No, do not add story. Just what is staged. So I don't need this. Now he checked what is actually in the commitment in this git stage, and then just generating this commit, so we can check it. So we can check how the commit looks like. Blah blah blah. So feed implement local components, override system and schema support, implement static strict directory, extend components discovery, yes, main yes, local components. The only thing that it didn't like put signed commit, so I will do it on my own. Let me do it for instead of this guy. Okay, let me remove these notations about performance and other stuff. So usually you can ask to be more, I don't know, short for this commit message, but for now it works. So git push origin main, and let me add local support for agents. So I've just pushed this. I'm opening this pull request. I'm going to create it. And another one, it forgot to add like closes some specific story. So I can go here. I need to like 50. We have a 50. So I can say I can do this stuff. Let's go here, and then let's say like clothes 50. Sorry, clothes 50, and let's push the same branch. So now let's go here and to check what is actually happening. So we have our change here, and he's like providing all the what we need. So like we have agent that was added, and this agent is aligned with our framework, and we validated it, and it has also like tests command that can be used to run some tests. Again, these tests are just simple examples, and they are expecting to believe together with this repository. So I can later like polishing it for Golang assistant to be aware of which libraries to use, what should be changed, and how to deal with them. So now what we want to have is just let's expecting for this feature to be merged, and then we just published a new release with this support. So now thank you all for being with us for so long time. Please sign up. Please just put us a star for our repository. Let your colleague know about us. Share your feedback. Thank you for your attention. Have a good day and bye.